Alright, let's look at Theorem 1, Part B. Alright, it says this, if B is between A and C, then neither C is between A and B, nor A is between B and C. Alright, so let's see, since the proving that it's not C is not between A and B, and A is not B and C are very similar, I'm going to do only one of them. And this part is actually done in the book. So I'll just say in book. Alright, so I'm going to focus on this guy. So try to say A is not going to be between B and C. Alright, so let's write a proof. Alright, so proof. Alright, conclusions and the justifications. Alright, as usual, we're going to write down the givens. So in this case, we know that B is between A and C. Alright, this is given. Alright, so then I'm going to just write down all we know. So A, B, and the C are distinct, right, just like before. So this is by definition, right? 3, and we know that A, B, and the C are collinear, right? So again, this is by definition, right? And 4, we have this equation, AB plus BC is equal to AC. Right? So again, this is by definition. All right. Then what we're gonna do is I'm trying to show that A is not between B and C. Right? So there are two possibilities. Right? So one is A is between B and C, or not A is between B and C. Right? So these are all cases. Right? Right, so let's pick on the first case. So this is our case number 1. This is case number 2. Because we want to establish that case number 2 is true, we'll try to eliminate case number 1. Right? So let's see. Let's assume that A is between B and C. Right? So this is our case 1. And let's try to get in trouble by assuming that. Alright, so A is between B and C, so they're distinct and they're collinear. And the equation it needs to satisfy would be, alright, BA plus AC is equal to BC. Right? So what we can do is we can do some substitution. All right, so we have two equations that we need to pay attention. So there's the equation right here from line 4, and here's the equation here. All right, what we can do is maybe we can plug, let's see, BC is the same thing as BA plus AC. Maybe we can plug this guy into here, since there's a BC there. Right? So by combining those two equations, we have this equation. Right? So you have an AB plus, right? BC is now same thing as BA plus AC. Right? And is equal to AC. Right? So this is from combining line number 4 and line number 7. Right? then we can actually cancel out. So AC is on both sides, so cancel those out to get 0. All right. Another thing we can do is here, BA is the same thing as AB. So doing a little bit of algebra, so 9. Right, BA and BA is same thing as AB, so you have a 2AB is equal to, there's nothing there, so it's 0. Right, by divide through by 2, we have AB equals 0. So I'll just say this is algebra. And also we are using the fact that the distance is symmetric, so I'm using D3. Right, to get that. And I'm going to go up here. So line number 10, right, it says that AB equals to 0, but the D2 says that the only way you can have a 0 distance is that the 2 points are identical. So this tells you that AB, actually, AA is equal to B. So this is from axiom D2. Right, but this is a contradiction because A, B, and C are distinct. So this contradicts line number 2. Right, so that's a contradiction. So therefore, we know that A, right, this means not, is not between B and C. Right, so this is by rule of elimination. And this is just a case number 2. Alright, so that would establish that A is not between B and C. And you can do exactly the same way. C is not between B and A. So I'm not going to do that part. Alright, that's it. I hope that this was clear.